Welcome to our Higher Maths course. My name is Mr. Wrightson, and before we begin, I would like to draw your attention to the slide layout. Each PowerPoint will take the same format, and we'll start by displaying this screen, which shows the 3 units of Higher Maths, and below that showing the key concepts and topics each unit will cover. Today we'll be doing the unit on applications and the topic straight line. In this slide, we can see that the gradient is as per Nat5, but note that the angle theta is always the angle between the straight line and the x-axis in the positive direction, as shown by the arrow now. We can now see that by using tan theta, we can find the gradient using this angle. Please complete this question. Once completed, click on the slide to reveal the answer. Now complete questions 1 to 4. These are from the Heinemann textbook, which is in your Teams folder, the answers of which are at the back of the book for exercise 1. In this slide, we can see that we've introduced the general form of a straight line equation in the form ax plus by plus c equals 0, comparing it with the 2 other forms shown below that you've encountered in National 5. The fact that we've introduced the general form of a straight line equation, as just discussed, does not preclude us from using the forms encountered in National 5. At the stage that we can rearrange the gradient formula as covered in National 5 to get to one of the forms of the straight line equation, y minus b, etc. Why not, as an exercise, try and rearrange this by expanding the bracket and get that in the general form as shown at the top of the slide. If we now consider 2 examples of a straight line, one with a gradient of 0, hence a horizontal line, and the other line a vertical line with a gradient that's undefined. Firstly, let's look at the gradient of m equals 0. If this line, which is horizontal, crosses the y-axis at say at y equals 3 in this case, then we can see that the equation takes the form y equals 3, hence there is no gradient, and all we have is the y-intercept value. Now let's turn our attention to the vertical line. If we look at that line, it's parallel to the y-axis, and wherever it cuts the x-axis, that describes the equation. So in this case, we've got x equals 2. Note the case where the angle theta is obtuse, and in this case we have a value of -2. The angle phi is the angle that we would come up with if we put tan theta equals -2 and solved for that value. I have purposefully left the last part for you to figure out yourselves. Consider the diagram to the left from your National 5 angle theory and the text at the bottom of the slide. Hopefully it should all make sense. That brings us to the end of our lesson today. We've covered the definition of a straight line, including a new general form ax plus by plus c equals 0. We've covered finding gradients and intercepts. Some of this is revision, some is new. Next lesson, distance between points, sticking to our straight line topic.